by my computer. All right. So should I start? Can I start? All right. So let me use Emacs. So this particular discussion, I'm talking about the code mybreak. Right. I'm going to go for section by section. This part is the first part should be fairly straightforward, just preprocessor, defining a symbol, and then I'm going to go through the main function. Okay, this part is just talk about ARGC, ARGV. Basically, it's a traditional way in C. How do we communicate from the environment to the program itself? Okay, so now the first part, I'm actually going to explain this piece of code here. It's basically I decide chunk size. Remember I said the chunk size is given by the input argument. In this case is the third argument after the command. So the third argument, whatever I got. So this code is called A to I. So anybody want to guess what is A to I? Yes, it's called ASCII to integer, A to I, okay? A to I, and then you have different kind of converter in C you can do. Okay, so essentially I convert whatever you put it in as a string because everything you got from ARGB is a character star. And that character star is going to be converted to an integer, and that integer going to times 1024. So just let you know, I actually check something. You see that I check the chunk size. If it's smaller than 0 or is greater than 1 gigabyte, and I'm going to just quit because the reason is sometimes if you what happened if you didn't put in a number, you just put in a random bit string or character string. So I basically check. I mean, by the way, there is another way to check whether the string you enter is a number or not. There is another facility to do that. I didn't do that here. I just check the range of the chunk size. Okay. All right. So now I'm here. This line, this is called F open because ARGV1, which represent the name of the file, of the source file, I'm going to chunk. I'm going to break. Okay. So ARGV1 is the name of the file I'm going to break. So I use the command called fopen. Fopen in Unix is a very popular facility called file open. So I want to, before I can manipulate the file, I have to open the file. Okay, and you can see that the first argument fopen is ARGV1, but the second one is you can see the second argument is a double quote, which is represent a string. Inside the string, I put R. R means that I want to open this file with read-only mode. So when you open the file, it could be, this could be R, it could be W. W means that you're going to write it from the beginning. Or you can put another one called A. A means you want to append after that. So I want to tell you that A is actually going to be useful for my heel, because my heel, you're going to append chunk after chunk. So I imagine if you want to do the same, do this part for my heel, then it's not going to be R, it's going to be A, append, okay? The first one may be W, but the second one, the rest should be A. Okay, so at this moment, do you have any question up to this point? Any question? Do you understand what I'm saying so far, or anything I should slow or faster? Okay, all right, just ask me a question anytime. All right, so then the next few lines is I essentially start to check whether I open this successfully. So fopen will return a pointer to the left-hand side of the assignment. So let's take a look. What is F? What is F? F is defined as a file. So this line, you can see that I have a file star F. So F is a pointer to a data structure called file. Okay, and in fact, that you have to include stdlib. This is all under stdio and stdlib in C. Okay, just in case you don't know that. So you can see that now I'm going back to here that the F is F open. You try to open the file with reaccess mode. So there are two results that open. You open successfully or you open unsuccessfully. If you open unsuccessfully, then the pointer of F is going to be null. So this is a typical convention in C programming. You try to open some resources, it doesn't exist or it doesn't allow you to access the way you want to access, it will return you a null pointer. So that's why I will check if the F is not equal to null, the next line. Because if it's equal to null, you basically say, no, it's not going to. Let's actually skip all the way to the end. What did I do? The else case, when it's null. You see that? I put it here in this line. It says that if I cannot successfully open, then I just say file, whatever, cannot be opened, right? Is that fair? Right? That's how we handle that. Okay, so now what we care is within this the curly bracket, which F is not a is not null, so it means that it's a real file. I have successfully opened it. Okay, so the first part I actually try to do is that okay, I try to break it, and I have a loop. You see that I have a loop here for I is equal to 0, whatever, and let's try to match up with the end of the loop. Yeah, the end of the loop is here. Okay, so basically inside my break program, I'm just going through this loop until it finishes. Okay, so now I'm actually really going to just explain the middle of the code starting from here. I'm going to actually use a different file to just focus on that part of the code. You see that? I'm actually, the code is already get down to, let me just say discussion.txt.c. Let's do .c. Okay, so this is the code we have. Okay, we're here already. Okay. All right, so now we're going to process the first part. The first part, I have to decide, okay, remember my goal over there on the board, I try to break the file, but I want to name each of the chunk in some convention. So I will be able to really create the file for chunk. So the first thing I did is the file name. I have to decide what kind of file name I want to have for this chunk. So what I did is, let me actually first part. Okay, this part is basically how this 3 lines here is basically help me to decide what should be the name of each chunk. So, okay, I do a malloc first. I actually create the space for that string buffer. That's actually going to be my, okay. I just want to tell you, ask you, have you learned the concept malloc and free from your ecs36b or equivalent? Okay, all right, good. So anybody who are unfamiliar with the concept malloc and free? Okay, so malloc and free is what we call dynamic memory management. You dynamically ask the runtime environment to give you a specific number of bytes. Okay, so that's a dynamic memory management. All right, so now I want to go to the question. I think somebody asked the question about B0, right? Who asked the question B0? Oh, you want to listen or you? Oh, okay, okay. So I'm just want to make sure you're here. All right. Yeah, so malloc, this line is essentially allocate a number of bytes. Whatever you give a number, it will give you number of bytes. But you're going to use that region of memory that the runtime environment just give it to you. And I want to tell you that this is the how do I say that, the madness or the evilness of programming language in C. Is that different runtime environment will do different things. So I just tell you that when there used to be a company called Sun Microsystem. and now it's part of Oracle. In some microsystem, their malloc, whenever they give back to you, is guaranteed every single byte is a 0. Means that they already zero your byte. Your byte is clean. Everything is a 0. Give it to you. And as you know, 0. What does 0 mean? C programming. That's a null string. That's a null or null string. If you want to use as a string, you know the first byte expects /0. That means it's end of string. So some microsystem, a lot of implementation did it that way. But some other system I noticeably was IBM. IBM has their own system. When you do malloc, they actually give you unpredictable garbage. So just give you random, whatever memory value has, you have that, okay? So you can imagine when I was a, like a young programmer back then, it was your program works perfectly well on one platform, but didn't work well on the other. So how do I actually make sure my program will work on all the platforms? I use B0. So B0 stands for binary 0, setting the whole range of memory to 0. That's exactly, just want to prevent that some of the content of my memory I got it from malloc got messed up. No matter what I did, I just basically wipe out that 0. So okay, B0 take 2 parameters. The first parameter is basically the address, a pointer. By the way, malloc returned the pointer or the memory address of the first byte of the memory chunk they're sending to you. And B0 basically say, I start to 0 every single byte, starting from that until I hit the count of the second parameter. So the second parameter max name is 1024. So B0 is basically starting to 0 everything for the next 1024 bytes. So that if you look at the malloc and B0, now you know. One is allocating that much memory. The second line is just 0, all of them. You have a question back there? Memory allocation. M stands for memory allocation. So there's a few things is malloc, alloc, calloc, C-A-L-O-C. It's all related to memory allocation. Malloc is mostly used, but alloc and calloc you use it occasionally. I actually only probably use once or twice in my programming career, but use malloc is like I have to use 20 million times per day. You believe that, right? Okay. All right. So that's a second license. Just you can see that I'm just creating those 2 lines. I'm just creating the buffer. Okay. I do want to show you a piece of code at the end. You see that malloc, you always go with free. You see here, I do a free. At the end of the loop, each iteration of the loop, at the end, I just free F name. So free is actually paired with malloc. So you allocate something, you free it back. So as a C programmer, now I'm reviewing some of the more difficult concept in C programming, is that if you allocate a memory, you didn't free properly, you will have something called memory leak. So for example, you allocate 10,024 bytes, but you only free about 512 bytes. So you actually have a 512 bytes hanging there. If you have a loop that just keep running like a web server, it's supposed to run 24/7, and it's going to eventually run out of memory. That's called memory leak. So that was one of the most difficult bugs to debug in C or C++ environment, because you have to do try to prevent, make sure that you don't have a memory leak. But on the other hand, those of you who learn Java, Java is using a different concept called garbage collection. And garbage collection, you won't have memory leak problem because automatically being retrieved for you. Okay, that's a big advantage of using Java. Any question over there? Okay. All right, so we took care of that memory problem just for the name. Let's actually move on to the next one. So this line is called, I just basically generate a name. You have multiple way of generating the name I like to use this facility called sprintf. Sprintf. So printf and printf is a standard way of printing out something. So there are two other library functions in the printf family. One is called fprintf. You print it to a file. printf. The other one is called sprintf, which is printing to a string. Okay, so over here, I'm actually doing a string. So I create this memory buffer called fname, and then you can see that I actually print the name using the way I do printf with this in the middle double quote. It's called format string. Format string is %s, which is a string I pick up from argv2. And then the second one is a %032d, which is an integer, a decimal, which I pick up from I. So essentially, this two together is a prefix, and then with a number that's increasing when the loop move up. Okay. Any question? Okay. I mean, if you want to know what is a %032d, I can tell you that it's just a way you can define a format string, which you filled up all the space with a 0, and the total number of digits included is 32, and then with that d. So that's why when you see the example, you see there are totally 32 digits. You can make it 16, whatever number you think is appropriate. Okay, good. All right, so now I'm here. Let me get rid of this name. So every code I have explained, I'm going to delete it, okay? So I already finished this one. And I already finished free the name. Okay, so now we're basically looking at the middle part of the code. So now I already create that f name. So you can see I call f open again. I call f open, I f open that name. But what's the difference between the earlier one when I call f open? What's the difference between this? Yeah, what?
This will write in the file?
Exactly, it's a write to the file. Why? I'm actually, the first one I'm going to try to read from the source. The second I want to write back to that chunk, right? So that's why you see I'm using write, W. I'm going to write to that. So that's how I open it. And I open it, I forgot to tell you at the end, I actually close it, right? After I'm done, I close it. I open one chunk, I close one chunk. Okay, open, close. So, okay, here is, I just want to now talk about my heal. If you do my heal, the first part generate the file name should be exactly the same, right? Because you want to actually be able to you think about that. This is the way I generate those names for my break. For my heal, you're going to do exactly the same. You're going to generate exactly the same name. But in my heal, instead of write to it, you're going to read to it. Because think about over here, after you my heal, you're going to open each of this block, and then you're going to read it in order to generate, restore this one, right? So one is read when you break it, sorry, recovery. Right, when you recover is actually the opposite. So you see the difference of the code so far is one character. You change the read to write. Everything else should be the same. That's why I said it's very minimal change. If you understand this code, you can actually just restore. Okay. All right. So I'm going to get rid of this. Okay. Again, you can see that I actually test whether TF is new or not. I want to make sure that the file is actually there successfully for me to write. Okay. So I'm going to get rid of this code. I'm going to get rid of code, and then I'm going to do the rest. Okay. So just let you know, after we've done everything so far, we only have about, let me see how many lines of code left. We only have about 23 lines of code. So far, you can see we look at the whole code. Now we only need to deal with this final 23 lines of code. And again, this is going to be, you're going to reuse the code a lot, okay? So let me actually take a look at this code. All right, so what I did is that now I have another loop. I use another index J to basically control that. the J is, you can see that I actually do chunk size divided by 8. So what is the chunk size? Chunk size represents the size of each of the chunk divided by 8. That means I just choose that every time I try to do the transfer from the chunk, sorry, from the original file to the chunk, that each time I decide to pick a byte. Okay, by the way, this part you can do whatever you want. You can do 16 byte, you can do 4 byte, you can do 1 byte. That's up to you. I just choose a byte because that was something. Oh, wait a minute. I try to remember why I did a byte. Oh, I know. Okay, there's a technical reason why I choose a byte. Because I was using a 64-bit computer. I was using 64-bit computer. So 64-bit computer, each of the memory movement, the optimal is 64-bit. 64-bit is 8 byte. So that's why I decide to do every time I do this movement, because later you learn operating system. When you do this, you are not really accessing your hard disk. Everything is actually on memory when you do this. And then after a while, they will flash back to your hard disk. So in order to speed up, I want to make sure that I utilize all the computers, the whatever the size that ultimately use the memory. That's why I choose 8 byte. But you can imagine the future, the computer become 128 bits computer and one day, then you might want to modify this for performance consideration. Okay. So, okay, that's why it's 8 byte. Now I remember it's because of 64-bit. Okay, so, okay, inside this chunk, what I'm doing is that I actually just keep shifting 8 byte from one place to the other place until I got the whole chunk size. Okay, so if the chunk size is 1K, then 1K divided by 8 is going to be 128. So it means that I'm going to do this kind of writing from the original file to the chunk for 128 times. Then I'm done with that chunk because each chunk is only 1024 bytes. Okay, so that's basically after you get through this particular loop, you will be done with one chunk. Okay, but remember we have an outside loop which is guarded by I, which is basically go through every single chunk. Okay, so we're done with this. So I'm going to get rid of this 2 line. And then I'm going to get rid of the last line here. So now this is inside here. What do I do? Those 8 byte, right? All right, so with that 8 byte, I actually create a buffer called CCC, which is 8 byte. This is a local variable using the memory on stack with 8 byte. And then I have a 2 integer, which is represent the status code from this 2 function, this 2 library function that's very important. I use here called fread and fwrite. Fread means that I read something from a file. And then fwrite means I write something from the file. And the thing is that each of the fread, fwrite will actually return the status code. If the status code is equal to 0, so let me tell you that CR actually okay, I know what CR stands for. CR stands for count for how many bytes you just read. So if you want to read 8 bytes, then CR should be 8 every time. But remember, you just keep writing it at the end, the last of the chunk, you're not going to get exactly 8 bytes. And therefore, when you do the CR, it's actually going to give you a 0, means that there's no more byte for you to read or for you to write. Then you will see that it is actually, that's the time when you should finish your program. Okay, so now really the only 2 lines you need to worry about. Let me get rid of this. So all this is just error code checking. Make sure you're done. Everything you care right now is this 2 line. Okay. Everything you care is this 2 line. Let me actually tell you what this 2 line is doing. The first line is read, fread. Fread is reading from the source file, just reading for from the source file for 8 bytes. So I want to actually use the board here. So essentially what I have a variable called CCC. CCC is 8 bytes. It's basically some kind of memory, 8 byte memory here. So the first line is reading 8 byte into this library from this original file. And the second one is actually writing that 8 byte to the chunk that you're going to put it in. Okay, so that's what that 2 lines are doing. So f read and f write. By the way, you can actually go to your terminal to see what is the if you do man f read, which you should actually do man a lot because it gives you all the directions. So if you do, you can see if you say man f read, it actually give you both f read and f write is as a Unix BSD library. And it basically tell you that f read take a full parameter and f write take a full parameter. So essentially, if you look at this full parameter, the first parameter is the memory region you try to read it to. So f read is essentially read from the file to this memory region. And then you have a middle 2 parameter represent controlling the size of the read. And similar to f write is essentially write from this memory region to this file. So is f read is reading from argument 4 to argument 1, but f write is writing from argument 1 to argument 4. So look at this. It's the difference in the main page. You can see that there is on my screen f write, the first pointer has a const. Const means it's a constant, means that you shouldn't change that. Because why? It's the source of the information. F write is writing from that constant to the file pointer, but f read is the opposite direction. So f read they actually don't have the const because you need to modify. It's not constant. It's changeable. Okay. Okay. The other thing, just want to tell you, you can actually do man f read or you do man f write. It will give you the instruction about how to use those library functions. So use man a lot, okay, when you learn the Unix environment. It's really helpful. Okay, so now let's try to understand this 2 piece of code. So f read is essentially reading 8 bytes from the file string to the CCC, this 8 byte. So I'm reading 8 bytes to that memory. And what I do f write is actually write from CCC to the file. But over here, I didn't use 8, I use CR. And what's the CR? CR is the return for the first parameter, because CR represents how many bytes actually I read. Because even though I read 8 bytes, maybe the file string only have 3 bytes left, then CR is going to be 3. And I'm not going to, write all 8 bytes. I'm going to write only 3 bytes. That's how it does. Okay. So just think about this for you to consider. If you think about trying to write from the chunks back to the original file, it's essentially we're going to reverse this too a little bit. So what you will do is that let me actually just write it up here. This is my break. Let me just imagine what I did with my heel. So my heel, this one is going to be chunk F. I'm actually reading not from the original F, but it's actually the chunk F. Oh, okay, chunk F is called TF. Okay, sorry, it's going to be TF. And this one is going to be F. Does that make sense? My heel. You see, I modify another like 1 character, I actually be able to handle that. Okay, so that's my quick introduction to the code. Any question? Okay, I'm going to, sorry, I need to take a break and I'll be back 1 second, okay? Let me, how do I?